was literally me and two other guys who were non-SpaceX employees. So the three of us were sitting in the middle of the ocean eating sandwiches and like drinking a Sprite and just waiting for Dragon to come back to Earth. And so you hear
there it is. Oh, yeah. There
no
we
kidding.
go.
Boom, boom, like the double sonic boom of re-entry. And they would compete amongst each other and compete for a beer or whatever and try to find it before the other people.
So you can find it fast. It's like a movie. So cool.
It's crazy.
3, 2, 1, 0.
Okay, so undoubtedly, Nick, your current perspectives on the engineering industry have been shaped by your past experiences, particularly at SpaceX, where you were the former director of spacecraft production. Could you share with us a little bit about how your time there influenced your outlook on life and also the engineering industry? How did working in such a dynamic environment alongside prominent figures such as Elon Musk impact your perspectives on the industry?
Yeah, so I ultimately ended up in a position as director of spacecraft production, which was awesome. I really enjoyed it. Had an amazing team around me. I think I had somewhere between 10 and like 13 managers at any given time, and they were all spectacular. Like, especially to connect it back to the university students right now. I didn't start at SpaceX as the director of spacecraft manufacturing. I don't know if you're familiar with the term hypergolic, but hypergolic are chemicals that spontaneously combust on contact with each other. So Dragon uses hypergolic chemicals as its propellant. So it uses monomethylhydrazine, MMH, and nitrogen tetroxide, NTO. That's not important. You don't have to remember that. I had literally never heard the word hypergolic before starting at SpaceX, right? So I did not know what I was getting into.
Wow.
I saw a job description that said something like, are you an engineer that likes to work with your hands and be out in the rain and the sun and sweat and mud and dirty and long hours? And I was like, yes, I want to do this. And so, I naively joined SpaceX as a test engineer, and I remember a guy named Brad Appel, who's gone on to do amazing things. He was an intern at the SpaceX test site at the time, and he was the one on my very first day showing me around and like what a rocket engine was, basically. And so, I don't know. I think it's hard to connect with people who have made it into senior level positions unless you really understand that. Like it didn't happen overnight. I started at SpaceX in 2009. It was between the last Falcon 1 flight and the first Falcon 9 flight. And so just coincidence, when I toured the Texas test site, I think it was like October of 2009, somewhere around that time frame, Stephen Trollinger, I think he's actually still at SpaceX, but he gave me a tour of the test site. He took me up onto a huge test stand called the Tripod, which is where we put the entire Falcon 9 booster and ran all 9 engines simultaneously. Absolutely amazing. But he took me up the Tripod, and I remember he's like, you should touch this, and like made me put my hand on the very first Falcon 9 vehicle ever. Right?
Did you trace your hand?
No, I had no clue what it was, right? This was 2009.
That's so cool.
It was like, this is a random tank. I was like, oh yeah, cool, big white tank, like whatever. Like, when can we go look at the rocket engines? But so I had the attitude of taking advantage of an opportunity that presented itself that sounded exciting. And I don't want to oversell it as any more than that. Like, I did not know that I was joining the SpaceX that exists today. That was pure luck. Like, I was joining a team of people that seemed exciting to work with, and the project seemed really cool, and rocket engines are awesome. Do you want to like have a job firing rocket engines? Yes, I do want to do that. So it was
playing in the mud and the rain.
Yeah, honestly, I was like, this is perfect.
Did you ever get to play in the mud and the rain? Was that promised?
Absolutely.
Awesome.
But what they didn't tell you about were the rattlesnakes and the black widows that are running around the test site in Texas. So we had to be careful about that. But I was following kind of my what I was excited about, and I just happened to stumble into a really cool opportunity. And so started as a test engineer, moved into various roles within the test engineering community. We called them test engineer, funny enough, not to confuse you. So yes, test engineer. But we had test engineer, test conductor, and test director, and those are basically the 3 positions that actually run the rocket engine test to make sure everything's working correctly. I had some amazing technicians that I worked with on a day-to-day basis. They probably taught me more about how to test rocket engines than the engineers did, to be honest, because they're out there turning the wrenches on the vehicles as well as the engines. They're suiting up in the level A hazmat suits, so like the Michelin Man suits, because those chemicals I mentioned earlier are super nasty. Like one drop in this room is potentially lethal type of nasty. Like they're really bad stuff. Yeah, but they're flight proven. They've been flown on Mercury, Gemini, Apollo, shuttle, etc. So it was it was easier for SpaceX to convince NASA that those were suitable choices. And they ended up working out great. But I guess what I'm trying to say is that the team that I was surrounded by at SpaceX was instrumental in my success, in believing in me and seeing opportunities to say, hey, you're doing a decent job over there. Have you ever considered being a lead test engineer? And it's like, well, no, but let's give it a shot.
Okay, now.
Yeah, why not? Let's do it. And then that working out okay, how about becoming a test engineering manager? And you're actually managing the team. And it's like, oh, man, like internally, I'm shitting myself saying, I know I'm not ready for this. Externally, it's like, oh, yeah, definitely, let's do it. Like, no problem.
Sort of putting a brave face on.
Absolutely.
I guess I can be the manager if you want me to.
Sure, I know nothing about management, but let's give it a shot. And I'd learned some things along the way, and I also had the side benefit of staying involved in the U.S. Navy as a Navy reservist. So, on 1 week in a month and 2 weeks a year, I would go and be an officer at the Navy Reserve Unit and help provide some guidance and support to my enlisted personnel, which was great leadership experience. But so it really complemented, I think, the experience I was having at SpaceX. I was there for about 9 years, a little more than 9 years. But
that's a long time.
One of the, I guess, most shaping projects of my career was when Elon made the decision that he wanted to reuse Dragon 1. So Dragon 1 was a cargo vehicle, carried cargo to and from the space station. It was not necessarily designed for reusability from the get-go. It splashed down in the ocean after its mission, which is a whole nother topic I'll talk about in a second. But that means that it was intentionally, a portion of the vehicle is flooded with salt water. So this is an aluminum and carbon fiber vehicle, which that's a galvanic couple, submerged in salt water, which is an electrolyte. Gosh. And so you create a battery, like a low-flowing current that just eats the aluminum, just disappears. Like I've never seen aluminum disappear. It turns into this like toothpaste consistency, like white toothpastey.
I think I know what you're talking. Sort of like a magnesium when it burns.
It's gross. Yeah. Anyway, so
not nice toothpaste.
Big challenge, right? So Elon said it was with Capsule 105, or we called it Dragon 5. I wanted to go back to the space station in 30 days after splashdown, and we went, oh man,
you what?
Yeah, exactly. No, but Elon is an extremely intelligent human, like super intelligent, and if he says that should be the goal, like I learned very quickly not to question it, just say, all right, cool, that's the aggressive goal, let's try to make it happen. Wow. And even if you fall short, right, like, well, I'll tell you exactly how far we fell short. So we never actually reflew Capsule 105, but we tried to an extent, and we learned a shit ton about what it would take to actually refly a spacecraft that splashed down in the ocean. We implemented some improvements on Capsule 106, and we reflew Capsule 106 after about 12 months, not 30 days, 12 months of refurbishment. So we tore it apart, verified that it was up to scratch, replaced any parts that looked like they were worn beyond our internal standards, and Capsule 105 went back to the space station.
Yeah, that's a really important thing. Like when you have goals, if you aim way ahead of where you want to be, like even if you get to where you want to be and you don't meet that super high goal, that's still way further than if you just aimed low.
Yeah, that's exactly it.
Exactly like what that was.
Like I learned to really appreciate that strategy. It's a balance. Let's say you're taking an engineering team at university and you're doing a senior design project. Let's pretend like you're building a UAV. If you say, all right, we're going to do this in 3 days and you haven't started yet, everybody's going to look at you like you're an idiot. Like, that's not possible. Why are you even bothering me with this? But if you say, hey, look, I know it's aggressive, but I think we can do this in 6 months, then they're like, oh man, that's going to be hard. But it forces you into this mindset. If you can buy into that aggressive target, not necessarily a pass-fail criteria, right? It's a target. Yeah. So buy into the target, and then it forces you to think about decisions you can make to help you meet that target. And so maybe it means you can't incorporate some feature that you wanted to incorporate, right? Yeah. But that's maybe a smart decision for the overall outcome of getting to the first flight very, very quickly. Yeah. And so we have a similar approach here at Hypersonix. So we're trying to fly DART serial number 1 on a really, really aggressive schedule, and we've internally acknowledged that, and everybody's high-fived and said, all right, yep, let's do it. Let's make it happen.
Yeah.
Do the little team handshake.
That's it. Like, we're in this together. Let's have a conversation about what features, like I mentioned landing gear earlier. So probably not appropriate to try to redesign the vehicle to incorporate landing gear. Let's just say, hey, that's off the table for serial number 1.
Yep.
Just so we can hit this aggressive target. And then hopefully we fail by as small a margin as possible.
Yeah.
That's the goal. Like realistically, it's going to be challenging to hit our target, but that's the whole point. And scarcity, the mindset of scarcity is sometimes a healthy thing, because engineers have a tendency to fill up the time that is available, the budget that is available, and will create complexity sometimes when in reality you just need to know, like, what's the simplest, fastest solution I can put in place.
Yeah.
And so that's an important mindset shift that a really aggressive target gives you.
I think it helps a lot too, being surrounded by people that you know you can rely on, and you know that their data is correct, and the decisions that they're making are also correct, that you can feel positive and comforted by the fact that when you operate this thing, it will work, and it's operating within those margins that you want. Like you said at SpaceX, I'm sure there's some very intelligent people there that looked at it. Is this feasible? Yeah, okay, yeah, it's feasible, but also like this is what can happen.
Yeah, let's push the limits, and you never have a perfect solution, so there's always compromises there, and you always have to be aware of the fact that there are going to be cases that you either haven't thought of and so didn't test for, or that you thought of and couldn't test for, and you have to make a decision to say, we recognize that we don't necessarily know the behavior if we're in that condition. We're going to decide to launch anyway or fly anyway.
Did that ever happen whilst you were at SpaceX?
I mean, I have to say yes. Like I'm confident it happened. We had a staggered risk approach depending on the type of mission. So if it was an internal SpaceX mission, we could take much more risk than if it was a customer-facing, let's say NASA. Especially now they're doing commercial crew flights back to the space station, right? So those flights have a tremendous amount of scrutiny placed on each nut, bolt, procedure, software line, you name it. Like it has been probably quadruple checked, if not more. Whereas when the company, I can't speak authoritatively to this because I'm not there anymore, but I believe that when they're launching Starlink missions where it's only SpaceX satellites on board, they're much more likely to, I do know they're doing this, so they'll be more likely to use a fairing that's been flown before, because now the risk is all on SpaceX, but the benefit is they learn more about how flown fairings work. Or let's use a booster that maybe hasn't flown before. And this is a kind of a sidebar, but another really interesting pivot that is happening is when SpaceX first introduced reusability of Falcon 9 boosters, there was a lot of uncertainty around whether the booster would be as reliable. And once the booster had flown 2, 3, 4, 5, 10 times, now the customers are like, oh, I don't know if I want a new booster.
Yeah, that one works fine.
This one works fine. Yeah, I would rather fly a flown booster because I know it's worked. It's worked 10 times. So it's been a really awesome thing to see the perception of reuse change. Yeah. Because like as a pilot, I also own an aircraft. I own a Beechcraft Bonanza. The most dangerous flight is the first flight after maintenance, because you don't know what's been changed. You don't know where something's been left. But, once you fly it and you're like, all right, everything's working, flying it again is, a non-issue.
Yeah. The sort of equivalent that I can think of in my head of the scenario is pretend that you're a NASCAR driver and you borrow your friend's car and you go to take it out for a drive. You know what it's capable of, you know what you're capable of, and you could like totally take it to the limits and do what you want with it, but you're not going to. But if it's your own car and you're out in some back road somewhere and you're a NASCAR driver, you're like, let's do this thing. I think that's the equivalent that I can think of in my head. The customer bit, you're borrowing the customer's car essentially.
Yeah, that's it. And it's a risk posture question. None of it is black and white. There's got to be some really careful consideration of the risks, and rocket launch has literally thousands of risks that all have to be considered in an intelligent way. And at the end of the day, someone or a team of someones have to put their heads together and make the decision that we are ready to go, in spite of potentially some things being imperfect.
Do you think there will be a reliance on artificial intelligence to do that in the future?
Yeah, absolutely. I think not necessarily artificial intelligence, but there are vast amount of data that the team is using and algorithms to evaluate that data already to give you the go no go on any given launch or risky activity. Because once the vehicle leaves the pad, that's it, right? It's actually before that the vehicle moves to internal power and internal control. So the human is out of the loop before it leaves the launch pad, with the exception of flight termination. But even flight termination is moving towards automated flight termination, where there's an independent system on board that's evaluating if the vehicle failed, where would it fall, and if that point is outside of specified safety zones, then it says, nope.
That's
like
so cool. It's so advanced, eh?
Yeah, it's awesome. It's awesome.
Like a fuse, I guess. Being like
it's
overload.
That's it. It's basically an independent GPS monitoring system that says we're so far off course now that if things went bad, we have the potential to cause risk to populated areas.
Yeah.
And so it just says, I'm not going to allow this flight to continue. Some vehicles have an explosive termination system, so it literally blows the vehicle up, or like splits it in half, and then the vehicle blows itself up, basically.
Wow.
Others have a passive termination system where it just turns off the thrust, and the vehicle just falls back to Earth. Yeah.
Could you sort of expand on some of the other projects you're working on at SpaceX and stuff like that? You can just...
Sorry, I kind of picked up there with
no
Cargo
worries.
Dragon reusability.
Super cool.
So that was really game-changing for me in my career. So I, working with my team of engineers and technicians in Texas, we brought Capsule 105 back to McGregor, Texas, into we called it Dragon Decontamination Building. And so we would offload the hazardous chemicals, we would offload the cargo, give that back to NASA. I got to be a part of the first ever commercial return of cargo and hand over to NASA. That was really exciting. And then, like I said, we tore the vehicle apart, looked in every nook and cranny and figured out what worked, what didn't, where there was seawater, and it was everywhere. Not inside the pressure vessel, that stayed dry, but outside of the vehicle, it was basically everywhere. Through the process of developing a new it's really a business process as well to reuse the vehicle, because we started asking questions like, what part number is the vehicle when it comes back from space? So when you get into configuration management, if there's a change to the vehicle's form, fit, or function, or any part's form, fit, or function, it should, in theory, have a new part number. And Dragon goes to space looking like one thing and comes back looking quite different, with panels off and parachutes deployed and the nose cone's gone, right?
What did you do to my car?
And so we're like, oh man, how do we get this back into our systems, into our software, to say, all right, we've now received a Dragon and we need to do some work to it to get it to a new state and send it back to space. So we really started asking fundamental questions like, what part number is Dragon when it splashes down in the ocean? And that led me down this rabbit hole of working with the configuration management team in Hawthorne, California at SpaceX headquarters. I actually decided to go back to school as well. So nights and weekends went and got an MBA to understand like finance and accounting, because the part numbers are tied to a dollar value. So it was like, all right, Dragon comes back to space. How much is this asset worth on our books? And the honest answer was we didn't know yet. Like, is it reusable? Is it not reusable? Should we be selling the vehicle to the customer all in the initial launch cost? Should we be depreciating it over its expected life of flights? Like, all of these questions started coming up. So educated myself the best that I could, and was given an opportunity to move to California to take over as the Dragon 1 product manager. So again, it was like, I'm not ready for this, but sure, let's do it. So moved to California, did that for about a year and a half, and then the timing worked out such that Capsule 106 had now been processed by the team in Texas and had made it back to California for refurbishment. And that was when I really moved into the manufacturing side of the house as the director of spacecraft production. So on top of the reusability portion, I was also responsible for a very large team, like 350, 400 people, depending on the time, who was building all of the new cargo Dragons, because we were still manufacturing new ones, refurbishing all of the flown cargo Dragons, and building the prototype vehicles for the crew vehicles, crew Dragons that ultimately flew. I think the last one that was finished by my team before I left the company was the very first crew flight, where Bob Behnken and Doug Hurley were the astronauts on board. So I was here in Australia watching that mission, and everybody celebrates after the rocket launches. They're like, oh, cool, yeah, we did it. But I'm sitting there sweating bullets until like it splashed down and those guys were back out of the capsule.
They're already at the bar and you're sitting there like,
yeah, it's crazy. So But being on the Dragon side, I was kind of used to that because the whole company would literally go to the bars in California after a successful launch. And I'm sitting there going, no, like I'm not even at the space station yet. Why are you guys celebrating? But no, it's good. I really learned to appreciate.
What got you so interested in manufacturing? Because you went from testing and then to manufacturing. I guess there is a link there, but what got you into that side of things?
Honestly, I wasn't interested in manufacturing. I saw it as another opportunity to grow and expand my skill set. I understood basic manufacturing practices, but again, I was surrounded by a team of amazing people. My boss, the VP of production, Andy Lambert, was absolutely awesome. He came from the automotive industry, building BMW and minis, like Mini Coopers.
That's cool.
Yeah, and so he was trying to bring at-rate production to rockets, which was a really cool problem. And then, like I said earlier, I had a team of somewhere between 10 and 13 managers, I think, maybe 14 at one point in time, and each had their own special area. So one would be responsible for like the structure of the vehicle, one would be responsible for the final integration, so putting all the pieces together and doing all the testing before it goes to Florida. I think I was selected for that role given my knowledge of Dragon, familiarity with what it's going to take to actually reuse the vehicle, having personally been in every nook and cranny of it, and sweating blood, sweat, and tears literally in the vehicles. And then I'll attribute a lot of my success in life really to being open to new challenges. So I was approached to move into that role. I didn't apply for that role. I remember talking, this may be a good lesson for some of the engineers as well, but I talked to my dad who works at a cruise line in operations, but he said that I was debating whether or not to move to manufacturing because it's a big career change. It's not engineering necessarily, although engineering knowledge is certainly helpful. And I said, look, I don't know if I'm ready. I had a bit of imposter syndrome going on. Why am I being selected to be a director of manufacturing? Wow. I thought I was relatively young, relatively inexperienced. And he said, Nick,
how old were you at the time? Sorry.
Would have been 6 years ago, 6.5 years ago. So I would have been 32-ish.
Wow, that's pretty young.
Yeah, but SpaceX has a lot of young leaders in the company. I think they do a really good job of recognizing capability early on and giving opportunities to demonstrate that capability. They're not shy when you fall short to say you're failing to deliver the capability you thought you would, but they'll give you the opportunity. And so I personally decided to take advantage of each of those opportunities, which is why it may seem that I progressed quite quickly.
So what did your dad think coming from a cruise line perspective?
Well, he's in operations, right? So he's responsible for all vessel operations for Norwegian cruises. So basically making sure the ships run. And the new builds are built as well. But the advice he gave me, which I thought was really useful, was that if the VP of production, if Andy's coming to me and saying, hey, Nick, we think you'd be a good fit for this role, then believe him. Right? He's probably thought about it a lot more, and he's taking way more risk to go out to someone and say, hey, you should come into this role than I'm taking by jumping into that.
It's on his shoulders
as well. And so that was kind of oh yeah, great point. If he already believes in me enough to give me a shot, I should believe in myself enough to take the shot. So I did.
It's funny that you both worked on ships. Your dad and then
ships,
different kind of ships.
That's true. Yeah, that's a good point. My brother works on ships too, actually.
Oh, really?
Yeah, for Norwegian cruise lines as well.
Oh, that's so cool.
Yeah.
What were some of the biggest challenges that you faced in some of these projects? Obviously there would be a lot because that's our entire job as engineers to solve problems. But what are some of the biggest challenges that you can think of?
I think the technical challenges are not always the hardest challenges. There's a lot of challenges related to business process implementation, and when you think about it, a lot of companies are using a lot of software to drive their processes, but you're limited by the software's capabilities in defining your business process, right? You can't really decide to do something that your software system is not capable of doing. So one of the big challenges we had, and SpaceX had a huge advantage because they had an amazing internal software team. So they were building their own internal enterprise resource planning system called Warp Drive, and we could adapt it quite quickly, way quicker than any other external product we would have purchased and put in place. But the challenge was figuring out the new business process for reusability that interfaced with the production team, with the design engineering team, manufacturing engineering team, finance, accounting, everybody else, to understand that, all right, this is a new thing we're doing. So we need different behaviors out of our software system in all of these different areas.
Connecting it all together.
That's it. Yeah. And it was we invented the process. Like we didn't had never really, the company was moving so quickly. I think nobody had just ever stopped to think, oh yeah, how do we handle this when the booster comes back, or when the spacecraft needs to be flown again?
Or if it lands in the ocean.
Lands in the ocean.
Like those little things. Well, they seem little from a distance. Oh yeah, it's just the management-y side. That's let's just do the technical stuff and make it work first. But like that's like fundamental to get it on track.
And like you can bring it back to engineering, because one of the final checks that a rocket company does before they launch is they compare the as designed bill of materials, so the list of parts by part number that need to be on the rocket, because that's the way we designed it, to the as built bill of materials. And so all of the issuing of hardware to the vehicle, and then the roll up of the smaller, lower level work orders into higher level work, all of that is a super complicated landscape with 1,000 line item parts or something like it's a tremendous amount of work that a software system manages. And so if at the end of the day you're looking at two lists of parts and they match perfectly, that's awesome. It means you built the thing you said. Yeah, I can almost promise that no company has done that perfectly. There's always like, oh man, it says we're using Rev A here when we designed it to use Rev B, or vice versa, whatever. And then you have to go through the process of explaining why that difference exists. So point is, the closer you can get your as built through the use of those software systems to your as designed, the easier you make your life at the end of the day.
And also quicker, I imagine, too. Less meetings about where is this part?
What's happened? Why did we use this? Is this a problem? Like, every once in a while you learn, like a company learns that a particular design is not suitable anymore, and you have to go through a containment exercise. And so if somehow a part snuck through that containment exercise and made it onto a flight vehicle, that could be a really big problem. And so,
of course.
The part, Falcon 9 Flight 20 was one of SpaceX's failures. The part that brought down that vehicle is about the size of your thumb. And so that little piece, it's a rod end. And so that rod end caused the failure, and we had to go through a huge containment exercise. And so anyway, having a system, like a software system that could handle a fast-paced, accurate containment, not just of what's in inventory, but what's already been issued to be put on vehicles, what's already been put on vehicles that are still in work, and what's on vehicles that are potentially at Cape Canaveral almost ready to get launched. Speaking
of failures, what are some of the failures that happened that you learnt from that you were able to integrate and fix up on the next project, sort of thing? You were just speaking about the rod end that was just that caused the Falcon to fail.
Yeah, that's one. That was probably the most significant failure I experienced while at the company. We went through a company-wide exercise to evaluate all of our processes to figure out how we ended up in that situation. I'll save you a long story, but basically we made an engineering decision early on, probably to save costs, potentially to save schedule. I'm not sure, maybe a combination of the two. But we purchased a rod end, a metal component that was certified for like automotive grade use, which isn't a problem. It's usually a lot less expensive than an aerospace grade part. It's not a problem as long as you perform sufficient testing on those parts. And so in this particular case, the part was a cast part instead of being machined out of a billet of material.
Oh, right.
And by chance, the one that caused the failure had a casting defect in it. And so
something out of your control.
Something you got to test, guys.
You got to test it.
So important.
You got to test it. And so obviously a lot of lessons learned there, not just about that particular part, but we investigated every single piece of the vehicle. We took kind of a guilty until proven innocent mentality. Each engineer had to prove that their system didn't contribute to the failure. It was not a pursuit of what contributed right off the bat.
Who done it?
And so by going through that process, we found we found a few situations where we could do better. And so we incorporated all those changes. But it's an ongoing effort. Like every single mission the company flies, they get better and better and better. And so the debriefing process, or the post-flight data analysis process, is an extremely important part of the overall mission and incorporating lessons learned.
Yeah, awesome.
Out of some of those failures or those challenges, I guess, what new processes have you or did your team come up with during your time there, and are they still utilizing those solutions that you came up with from those problems, do you think? Like, are there any examples of that?
Yeah, I'm sure. I mean, that one related to testing, obviously we went and scrubbed every single line item on both Falcon 9 and Dragon, and we made a determination of if we needed to increase the level of testing. So sometimes you might do what's called batch testing. So if you, let's say you get a bag of screws, if they're all from the same parent material, made by the same process, you may not need to test every single one. So batch testing, you maybe take 2 or 3 and you go and pull on them until they break, and you're like, cool, those broke where we thought they should. Yeah. So the material's good, the process is good, we're happy.
Yeah, cool.
Other cases, it's much more important to ensure that each and every single part gets tested to the full loads it's expected to see in flight.
I guess that's why the casting problem occurred.
Yep, we missed that. We should have been testing every single one. The company failed in that respect, but learned the lesson through that process, and now has updated their testing procedure. I think they also upgraded to the aerospace grade parts as well, out of an abundance of caution. But I don't know if you guys are familiar with the Swiss cheese model, but you can Google.
I've heard of it.
Yeah, it basically, if you imagine like a stack of multiple slices of Swiss cheese, and each slice is some sort of protection against failure. No protection is perfect, right? They all have holes in them. And it's only when those holes just happen to line up that a failure sneaks through and causes a major accident or anomaly. So like the company went through an extensive process to either add or reorient all of the slices of Swiss cheese, if you will.
So there's no holes that line up.
To prevent the holes from lining up.
Until a rat comes along and chews a hole through it.
There's always something. Like unknown unknowns are always going to be a challenge. So you do the best you can with all of the available knowledge, and hope that your engineering processes are robust.
I want to ask as well, how similar, so moving on from SpaceX, after you moved on from that company, how similar were some of those challenges compared to where you were at Gilmore Space, where you're the chief of staff and the program manager as well? And which opportunities or projects there really grew your skill set? Was that similar to SpaceX as well in that sense, or what did you see that was different?
Yeah, so I'll highlight again that was a situation where I felt a bit in over my head, like imposter syndrome for sure. So I was, I had just left head of production role at SpaceX and was asked to move into a head of manufacturing role originally at Gilmore Space. But I was the only one, right? Like at SpaceX, when I left the company, it was probably 7,000 people or so. Like it was a huge company. I had more knowledge around me than I could absorb on any given day. So many resources to say, hey, how do I handle this situation or this new problem? And then Gilmore was about 30 people, and I was going to be driving all of manufacturing for the rocket side, which I didn't work on Falcon 9. I worked on Dragon. So I understood the vehicle quite well, but really didn't spend much time on Falcon. So I was nervous to step into that role for sure. But anyway, so I walked into the warehouse down in Helensvale. I remember looking around, it was a big empty warehouse. I was like, oh, this is great. This must be like our inventory location or something. I was like, when can we go see the actual manufacturing facility? And they're like, no, this is the manufacturing facility. You got to get it up and running. And it's like, oh man, we got a lot of work to do.
So come and solve some problems.
Yeah, solve some problems.
It's like a deserted island situation, bit of a Tom Hanks castaway. Chuck you on an island. Here you go. What can you make with these palm trees?
Go. Yeah. And then also it has to launch to space.
The important part.
The important part. Yeah. But
that's crazy.
Again, it was like almost unconsciously I switched into like, oh, okay, like I kind of know what we need. I know what the fundamental building blocks to create a system and a team that's capable of building aerospace vehicles, because I just lived in it.
Because you had multiple roles in all aspects of production. Testing everything.
Yep. And if I didn't have the opportunity to sit in a particular part of the organization, I interfaced with almost every part of the org, which was really such a privilege, and I learned a lot through that process. So just got to work, rolled up my sleeves, got to work, working with the team down at Gilmore. I worked directly for Adam Gilmore, one of the co-founders, and he offered me to move from head of manufacturing into a program management role because honestly the company wasn't ready for a head of manufacturing. There was nothing to manufacture yet. We were still designing the Ares orbital launch vehicle. So I helped originally with just at the very end, getting to the finish line for the attempted launch of SR0, which was a sounding rocket, hybrid-powered sounding rocket. So I moved here in June of 2019, and in July of 2019, they let me, a newbie in Australia, having never been to Australia before, by the way, drive the team 3 days out into the outback to a little town called Boulia, and then went 100 Ks or so southwest of Boulia to the middle of nowhere. Yeah.
Whoop whoop.
Yeah, right. And I'm literally in the lead vehicle saying, "Yeah, follow me, guys." I have no clue where I'm going. I mean, we had planned, of course, but
that's a long trip.
It was wild, and so we got to drag the vehicle out into the middle of the desert. We attempted a launch. We had a failure, unfortunately, but we learned.
Oh, the vehicle came too.
Yeah, vehicle, the team. We did a full remote launch from a remote launch trailer.
You're like, follow me, guys.
Let's
I
go.
know where we're going.
Yeah.
Push bashing.
Yeah, exactly. Honestly, it was not far from that. So amazing experience. Attempted that launch. The launch failed. We ultimately overpressurized the oxidizer tank. It was a design flaw that had been built into the vehicle for probably a year and a half prior to that, and we just didn't necessarily pick up on the signs that maybe we could have picked up on before and prevented the failure. But with the team down at Gilmore, conducted a thorough anomaly investigation based on what we did at SpaceX when Falcon 9 Flight 20 failed. It was like, all right, cool. I know how to do an anomaly investigation. Let's do this again and dig in a bit deeper, and worked with the team there to figure out not only what the true root cause of the problem was, but what were the contributing factors. Even thinking about things like schedule pressure, like did we push the team a bit too hard and force them to make decisions where they maybe weren't quite as thorough because they didn't feel like they had enough time. And so moving into leadership roles, you have to be conscious of that. Like it's easy to set an aggressive target, but you do have to keep in mind that that's going to create behaviors that you may or may not want in the team.
That's something you wouldn't really think about often. Hey, that's a really important thing to pick up on. Like, how is this goal going to affect the staff working on it, and will it actually cause them to make, mistakes?
Say suboptimal decisions, right?
Yeah,
Because you're putting them in a position intentionally. You're saying you're putting them in a resource constrained position. Time is the resource here, and saying, I need you to have whatever ready to go in 2 months. And they go, well, shit, that means I can't test this thing. I can't evaluate this thing. I can't do that extra level of scrutiny that I would have normally done. But a schedule is like a gas filling a room. Like whatever space you give it, it's going to fill up into. And so if you set the goal 4 months out, sure shit, it's going to take 4 months. If you set it 2 months out, then you may have a chance. But anyway, so point is, it is very important for leaders, especially young engineering leaders, to stay really in tune with their team, like foster open communication and transparent communication, and accept a level of honesty from the team where if they say, look, we can do that, I can deliver the thing for you in 2 months, but it means I'm not going to be able to run the thorough test that I had planned to run. And you have to be either, as the manager, be willing to accept that risk or move the date and say, all right, well, how much more time do you need? 3 more days? All right, cool, let's do it. 3 more months? Probably not worth it. Let's take the risk. So
and I think it helps a lot understanding the background of that person a little bit more too, and getting to know them on a more personal level. Like they could say, oh yeah, I can have it done in 2 months, but then you can ask them like, oh hey, like they could be having a child, they could be getting married soon, like who knows what's going on like in their lives. So it's good to also have that deeper personal connection, I feel, as a leader, and understand truly what's happening in their lives.
And also understand what sort of person they are. If they're very detail orientated already, you can probably bet that they're already going to do that testing, and they've already put that in their schedule when they've talked to you about that.
And those are amazing points you guys are making, and something I probably learned later than I would have wanted to learn is like the importance of understanding each individual and their nuances, because there'll be people on your team who are have a really big risk appetite, and they're like, yeah, screw it, we'll make it happen. And then you have others that are like naturally risk averse and like, oh, I don't know, I want to do this extra testing.
The voice of reason.
But you're like, as a manager, your conversation with each of those people might be quite different. Like to the person who's really aggressive, you might have to temper them a little bit and say, hey, look, I understand you want to go fast, we got to be thorough as well. And to the person that is ultra risk averse, you might say, hey, I know you're being ultra thorough, I appreciate that, but in this case, I'm willing to take on the risk of going a bit faster and avoiding whatever the thing is. So it's tricky. People management is quite I'm still learning.
Yeah.
Okay.
It's like the devil and the angel on your shoulder.
Yeah,
And one voice is going, do it. And the other one's saying, don't do it. And
Yeah,
you gotta
as
like
a manager,
be the
you're
one in the
both-
middle.
You're both voices. That's the hard part. Yeah, it's challenging.
Yeah.
But anyway, so yeah, the Gilmore process, the failure investigation was a really great experience, and I honestly believe that was like a key inflection point for the company when the investigation team delivered that report back to Adam, the boss, and said, here you go. These are I think there were 23 recommendations that you need to carry forward to ensure success and avoid the mistakes that have been made previously. And like a good boss, he took that on board and said, awesome, this is great work, very important. And then he handed it back to me and said, now go do those 23 things. And so we spent the next 2 years or so implementing a wide range of improvements to process and culture and safety and a number of things to make sure we didn't repeat those mistakes. So yeah, I'm really excited. They're making great progress towards a launch, an orbital launch attempt this is like clean sheet design. I can't emphasize that enough. Like literally a blank sheet of paper. Hybrid rocket, which is a first if it makes it to orbit. Australian parts by a vast majority of a like Australian team.
That's awesome.
Built in Australia. Wow. Like it's amazing capability for the country when they're successful. And it may not be on the first flight. First flights are very, very risky, but they will definitely be successful.
Can't wait to see what comes out of there.
Oh, it's going to be awesome.
It's going to be amazing.
And they're simultaneously building a launch site as well up in Bowen.
It sounds like you've done like a 180. You went to SpaceX with no real expectations and didn't know what to expect, and then they built you right up, and then you go to Gilmore with sort of these other expectations, and then you're like, oh, okay, maybe this is we don't have the resources to do this. Oh, that's okay.
That's the drawing board, and let's do something else.
Yeah,
it's awesome.
It would have been such a shake-up to have those different experiences, I think.
It was, and I can't say that I did it perfectly. Like, I don't want to say that, but I think we set the team on a really great trajectory, and they're still on that trajectory now, and hopefully this year they'll execute that first launch. We'll see how they go.
Fingers crossed.
And then at some point, so you'll see I moved into a program manager position, which that led the Ares launch vehicle all the way through almost to critical design review in the systems engineering process. So matured the vehicle quite significantly. And then I had to make a transition into the chief of staff role, which between us, I just invented that overnight. So the U.S. government basically said, hey, we're not comfortable with U.S. citizens helping Australia build rockets right now.
Wow.
So you can't be responsible for the technical side of things, which is okay. I wasn't really doing a ton on the engineering side anyway. But so overnight, literally wrote a chief of staff job description and say, hey, Adam, I can still support the company in these ways that are in line with U.S. regulations. And so that meant that I had the opportunity to take on work health and safety, human resources, facilities, logistics, and some other departments, grants.
What were some of the other names you came up with? What made you go with chief of staff?
Honestly, I was just like, I just Googled some things, and I was like, what do you call someone who's responsible for all these things?
Yeah, because that's what you're already doing.
It is. And
you didn't spin a wheel?
I should have. It would take too long to make the wheel. Make fast decisions. So I really, my career ambition was to move into a COO role, chief operating officer.
That's
which
a good idea.
You're typically responsible for a lot of those things anyway.
Yeah.
And so in a weird kind of twist of fate, and I probably didn't even realize it at the time, it was a great training ground for me to now learn the non-technical side of the business. Like I'd done tests, I'd done a little bit of design engineering, product management, manufacturing. I'd always worked very closely with the finance teams and work health and safety teams at SpaceX, but now I could directly manage them and understand how to be a good manager for those departments that are traditionally considered support departments, but play such a critical role in the overall success of a company. So I was lucky enough to stay in that role for a couple of years at Gilmore, and then had this opportunity at Hypersonix come up to move into the full-fledged COO role.
How good is that?
I do have some limitations from the U.S. State Department still, so I have to be conscious of those. My focus right now is mostly on the human resources and IT side, trying to get the team set up for success. But yeah, it's a little bit of like deja vu, to be honest, because I started at Gilmore when they were 30, took them to 180. We're 23 today, and a lot of the conversations we're having about expanding our facilities, putting in place a robust IT and cybersecurity architecture, developing a recruiting process, and selecting an HR information system. Like, I did all of these things at Gilmore over the past 3.5 years. So
just combining what you've learned.
It's right. Yeah, that's exactly it. And so it's been an unintentional, but really, I guess, interesting and beneficial journey going through all of those different areas. And there's, as I've kind of talked through, there's a number of points in my career where I've made a pivot and didn't see that pivot coming. And I think my openness to accept a new challenge and just give it a shot, have a go, even if I didn't feel like I was necessarily suitable for that next step, but kind of overcoming the imposter syndrome and just faking it until I make it. Like, that's all right. Like, give it a shot. Someone believes in me enough to give me a chance at this. I'll give it my best. And I think, again, bring it back to university students, like developing habits of working hard and having a positive attitude and challenging yourself to learn difficult things. Like, those fundamental skills will never let you down. And so you can like take those to any job you go to, any country you move to, any new industry. Like, I'm confident I can move into a number of different industries. And I might not know the ins and outs of that industry on day one, but I do know how to make intelligent decisions and problem solve and work with a team and do all of those things. And I can learn the other stuff.
Yeah, exactly.
That'll come with time.
It's just the hard skills, I guess, that you need first.
And there's so many cool opportunities in the world right now, like outside, like space, like whether it's satellite space or rockets in space or hypersonics that are doing amazing things. But outside of that, like the medical industry is doing incredible stuff, like renewable resources. There's some amazing opportunities there. So
what a good time to be in STEM.
I know, right?
It's awesome. Like, it's so good. And I guess I skipped over this part, but when I went to the Naval Academy and selected,
I was about to ask about that.
So you have to make a choice, I think, in your second year, what your major is going to be, because you can do like trial days where you basically like follow around a English major, follow around a history major. So like looked at a couple of those and I was like, I can't pay attention to any of this stuff. I was like, the only thing that's going to keep my attention,
I need numbers.
Aerospace engineering. I was like, I want to really understand how airplanes work.
Yeah, that's cool.
And so that's why I made that selection. And it had a bad reputation for being one of the more challenging majors at the school. But the reality is, if I tried to major in like English or history or something, I would have failed for sure. My brain doesn't work that way. I don't have the natural interest. So
could you tell us a bit more about the Naval Academy and your experience in the Navy and sort of how it affected the rest of your career?
Sure. So Naval Academy, it's a 4-year school similar to ADFA, if you guys are familiar. But it's a 4-year school where, on top of completing a Bachelor of Science in an engineering field, which should probably take 5 years, but they cram it into 4 because why not? So on top of doing that, you're also getting officer training. That's both during the school year as well as in the the U.S. You take your breaks in the summer, and so in the summer you go and you do some sort of training with a military unit somewhere around the world, and that was a really cool experience because I got to fly a helicopter, Black Hawk helicopter, a Seahawk helicopter, I should say. My Navy friends are going to punch me. Got to fly a Seahawk helicopter, got to spend some time on a submarine, got to go and pretend like I was a Marine Corps officer, because the Marine officers actually are graduates of the Naval Academy as well. Like, Marine Corps is
don't yell at a few people.
The Navy. So I tried that. I wasn't very good at it. It's not really my attitude, my skill set. But it gave me the opportunity to try a bunch of stuff and see if I liked it. And I knew from a really, really young age, like seriously 3 years old, I think, I was dressing up like Maverick from Top Gun, because the original Top Gun. So I have pictures to prove it. Like, I made up my mind then that's what I wanted to do with my life.
Send us those pictures. We'll chuck them up on the Instagram.
I'll send it to you. Wanted to be Maverick when I grew up. And then potentially maybe an astronaut. And so I made my mind up in seventh grade, so middle school for us, and that I was going to go to the Naval Academy and that I was going to try to fly jets off of aircraft carriers. So that's kind of how I ended up going down that path. And I got lucky a number of times being selected because, the Navy, a lot of things are driven by the needs of the Navy. They may not need fighter pilots at any given point in time. And so to go down the path and not only hit the timing such that there is a need, but also have a performance that's high enough to make the cut for your first choice of selections was really lucky. And so I navigated flight school along my desired path, which was awesome. Selected to go fly F-18s out of Lemoore, California.
What an experience.
But yeah, it would have been. So, but I actually deviated. So that was the time that I said, you know what? the big bureaucracy of the Navy is not necessarily where I want to see my entire career going. So I transitioned to the Navy Reserves as an aerospace engineer and joined SpaceX at the same time. So it was, really crazy year for me, 2009. But
look where it's taken you.
Yeah, it's been a hell of a ride. I mean, even if you asked me 5 years ago if I was ever gonna work for a hypersonic aircraft company in Australia, I would have thought you were crazy. But here we are.
Yeah, well, on this topic of, I guess, of your history and how you got to where you were, let's take a little trip down memory lane, if you will, to your early days in the engineering industry, or even before the engineering industry. So before SpaceX, before Gilmore, what was the initial spark that made young Nick want to reach for the stars? Like, quite literally, you mentioned dressing up as Maverick.
Yeah, Top Gun.
So
it was it.
Just Top Gun?
Yeah.
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 And you watched it and you're like, oh,
Top
do
Gun,
that.
2-word answer. I don't remember. Like, I was born in 1984. I think Top Gun came out in 86 or something. Yeah. So according to my mom, when I watched Top Gun, I said, that's what I'm going to do with my life. And of course, she kind of laughed it off. Yeah, sure. But no, that was it.
That shows just how much influence movies have on people.
True.
Hey,
yeah.
Like,
and bring it full circle. I don't know if you guys have seen the most recent Top Gun. You're both nerdy like I am.
That was good.
Oh, so good. But what's Maverick flying now? Hypersonic aircraft.
Yeah, the start. Right? Skunk Works one.
Yeah. Pretty cool.
You know what? That's a bit ironic.
I know.
So, who knows what's going to happen? Maybe we need a movie about engineers.
Yeah.
Maybe that's what needs to happen.
Every
Although I can't
movie is
imagine it'd be
about
very
engineers.
exciting.
It's just in the background.
Yeah.
And you just need to bring it more to the front so that people can sort of see how cool engineering really is.
No, that's really, I've been so fortunate, I guess, from a young age to have a vision of what I wanted to do. And I remember telling adults when I was younger, like I was a Boy Scout as well, like went through Eagle Scout, and I remember telling people in my troop or parents or whatever that I was going to be a fighter pilot when they grew up. And they would kind of like chuckle. I was like, oh yeah, okay, sure you are. I was like,
okay, Maverick.
What are you laughing at, bro?
I couldn't understand why they thought it was funny. I was like, no, that's what I'm going to do. So just like, believe me. Not exactly the path I could have predicted, but it's been really great for me and put me in some awesome positions.
So awesome.
You stuck to your interests.
Oh, for sure.
And that's what matters, I think.
Yeah, and I think that's a great takeaway as well. It makes it very easy to show up to work and be excited about what you're doing. I mean, I don't want to paint an overly rosy picture. Like, nobody loves doing... I like spreadsheets. I was going to say spreadsheets, but I do like spreadsheets. But there's certain, business activities that just aren't fun.
Yeah.
But when you're contributing to a mission that's so inspiring as SpaceX is in taking humanity to Mars, or Gilmore Space developing real capability for a nation, and Hypersonix shrinking the world to a 2-hour trip anywhere. It's hard to get bogged down by the little challenges on a day-to-day basis, and it's really nice to be inspired frequently by the overall mission.
It's really inspiring. Like, you followed your dreams and you didn't let anyone tell you, no, you can't do that. You're like, what are you talking about? I'm going to do this.
Just do
and
it.
you just got to exactly where you want to be.
I got lucky.
How cool is that?
Yeah. I mean, luck plays a huge part, but I think attitude...
attitude's so important.
Attitude is a really big one, and work ethic as well. I've worked quite hard in every position, but it's just my nature. Like, I enjoy working hard. I don't really like doing things kind of halfway. I'd much rather just put my whole heart into it.
And getting to see what you've also put your effort into. I guess it's very rewarding seeing that physically happen.
It's awesome.
I've mentioned that a few times in previous episodes, and I love aerospace so much because it engages all your six senses. It's got sound, you can smell it, you can feel it, and it's just such it's such a visceral experience. It's nothing else compared to in the world, and you get to experience that and be like, oh, I've worked on that. I've had a part to play in that, and it's such a nice experience.
That would be so rewarding.
I'll give you two stories around that line. So one, there was a period of time where SpaceX was building a new rocket engine test stand, and so they were instead of testing the entire Falcon 9 vehicle on that tripod I described earlier, big, it's 30-meter tall concrete tripod. It's a huge thing.
Yeah, that's pretty.
And it's rated to 2 million pounds of thrust or something. It was left over from a previous company. It was one of the reasons why SpaceX selected that site in McGregor, Texas. But anyway, so they usually tested the full Falcon 9 vehicle there. But when you test Falcon 9, because of how much energy is stored in the propellants, you have to be like 1.5 Ks away. You have to be really far away to even just watch it. And so
yeah, that's crazy.
Yeah, it's loud and like you can feel the rumble. You're still a long way away. So anyway, while they're building this new test stand, they needed to continue testing single engines. So they put single engines up in this tripod. And when you test a single engine, you don't have the huge rocket worth of fuel above it. So what's called the quantity distance or the clear distance is much, much smaller. There we could stand like 100 meters, not even, from the center of where this engine is firing. Remember, it's 130 feet, like 35 meters or so in the air.
Yeah.
Firing. Wow. So you're like looking up at this rocket.
That's not far if you think about how tall it is.
It is scary close. So you're standing there and like the cavity of your chest is rumbling and you literally cannot hear anything. Like I could be screaming at you from a foot away.
What?
It was wild.
That's
I
so
have
cool.
Quite a high risk tolerance, and that was one situation where I was like, "Oh man, I'm too close."
Died.
You know what? I'm jealous of the rattlesnakes. They get the best view.
They get scared.
Oh,
yeah,
that would be the
slither
best.
Away.
I'd want to be a rattlesnake in Texas watching space launches every day. That'd be the
So that was one amazing experience.
Follow your dreams, Jacob. You'll get that.
Well, Nick wanted to be a ladybug. I want to be a rattlesnake.
Put your mind to it. Another is, I think I kind of skipped over this, but I was lucky enough to be selected to be part of the recovery crew that went out into the ocean to
that's awesome.
receive Dragon back from space.
Cool.
So it was literally me and 2 other guys who were non-SpaceX employees. One was the boat driver. We were on this little rigid hull inflatable boat, and the other was a diver. It was like a marine salvage diver.
Yeah.
But we used him to help rig the capsule up with lifting equipment so we could bring it onto the boat. So the 3 of us were sitting in the middle of the ocean eating sandwiches and like drinking a Sprite and just waiting for Dragon to come back to Earth. And so you hear
there it is. Oh, yeah.
no
There
kidding.
we go.
You hear boom, boom, like the double sonic boom of re-entry. And then compete amongst each other and compete for a beer or whatever and try to find it before the other people.
So you can find it first.
Yeah, and so when you
it's like a movie.
And it breaks the
So
sound
cool.
barrier, it hasn't deployed the main parachutes yet.
Yeah.
And those are huge, so very easy to see. And so like the capsule itself is quite small when it's at that altitude and moving that quickly. And so it was a real competition to see who could find it. But
is part of your brain like, it better not hit us?
yeah, so
oh crap.
there is what's called a no-shoots ellipse. So it's an elliptical area on the surface of the ocean where if Dragon's parachutes don't open, there's a probability that Dragon impacts.
Yeah, okay.
So we, the 3 of us in that boat, were the only people allowed inside the no-shoots ellipse for risk reasons. So there was a non-zero chance that I was going to be killed by a spacecraft.
Best way to go out.
Yeah, honestly, put that on my gravestone.
Yeah.
That'd be the best.
Yeah.
If anything, I don't want to fall down the stairs and die. I want to get hit by a spacecraft. That'd be the
that I made.
that I made.
I mean, there's a lot of safety.
Invention kills the inventor.
But, still, that was an interesting experience. And then you talked a bit about having pride in the thing that you contributed to. So one that stands out to me is when I was the director of spacecraft production, I worked with one of my teams that built Dragon solar arrays. So they power the capsule while it's in space.
Oh, that's awesome.
And so I actually got to play technician for the day. They were kind enough not to make fun of me for screwing things up too bad, but they guided me through how to actually build part of the wiring harness on these solar arrays. So I can literally say I helped build the solar array. And
that's awesome.
I remember watching that launch, and then a few minutes after launch that the solar arrays deploy, and watching them deploy correctly, and like the sense of pride that I had, honestly made me tear up a little bit. I birthed this thing and it's working. This is amazing.
This is my child.
Yeah, it's just such a cool experience.
My child's walking for the first time.
Yeah, but as an engineer, these ideas come out of nowhere and they work their way onto a napkin sketch. And
imagine seeing
CAD,
that,
and they
napkin,
real, right?
Flying
and
spaceship. That's so sick.
No, it's wild, and I feel really priprivileged to have.
That's incredible.
Super tiny part, right? But it was a really great experience.
I guess moving on from that, also on the topic of that as well, out of all of these amazing opportunities, what's been the best one that's come your way throughout your entire career? It could be a killer project, a globe-trotting assignment, or even just some sweet skills that you've picked up. What's been the most
biggest highlight
of your career? I think being on that Dragon recovery team was probably the biggest highlight. I mean, it was a carefully selected team. There's probably 10 of us, less than 10 of us, that would go on to the recovery vessel. We'd go about a day and a half, 2 days out to sea in the Pacific Ocean. Depending on weather, we would have to time Dragon's re-entry and our position where we would be. And my particular role was as the responsible engineer for the hypergolic system, so the fuel system on board Dragon. And so
now you know what it means.
Now I know what it means. Yeah, I had to learn for that trip, actually. No, I'm just kidding. So working with the technicians, many of which were on my team in Texas and would come out to California for that specific mission, it just it felt like we were selected as part of a knowledgeable, capable, trusted team, because we were all really young. And we're like going out on this boat in the middle of the ocean to go get a spaceship, and there's like no adults around, and it's like
young Nick would have dreamed
put the kids out on the boat.
Right, yeah, like who's supervising?
It's like putting the kids in the kiddie corner and giving them crayons.
That's it. And I was like, oh wait, I'm supervising it. Like, this is interesting.
That's so cool.
So yeah, it was a really awesome experience to, I guess, thinking about it right now, like what was amazing about it is we as a team had demonstrated our capability to the point that the company trusted us with such an important objective. Yeah. And so that was really cool to have like the confirmation of our own skill sets and capability to be trusted to do that.
What a great feeling.
That was awesome. It was really awesome.
I am responsible.
I remember when it got to a point in my career where I was leading bigger teams back in Hawthorne, and I think my boss kind of said, hey, we can't necessarily afford you to have multiple days out of the office on this mission to go recover a dragon. You're going to have to train somebody else to do it instead of you. And I was just like, oh no, like I want to keep doing it, but it's just the evolution of a career. It happens.
Yeah, you got to give others the shot.
Yeah, I guess. So I can't remember. I think I did 3 or 4 recovery missions, something like that, and they were all unique and challenging in different ways. But yeah, such a cool experience. And
you don't want to always be the one in the line of fire of falling rockets, I guess. You got to get other people.
That sounds pretty fun.
Yeah. As long as the weather's nice, it's pretty good.
As well as that, so I'm guessing along your career you've had parts where things have failed and fallen apart. You mentioned that little rod before as well. So that's often part of the journey towards success, and I guess every engineer faces these challenges. Can you share some of the obstacles that you've encountered on your path to becoming a successful engineer, both personally and professionally, I guess? And what was the biggest hurdle you had to overcome, and how did you approach it? Could have been a skill issue, could have been a personal issue. What was that?
I mean, there have been like challenges the entire way. I mean, I mentioned to you guys at the beginning when I joined SpaceX, I really didn't know what I was getting into. I didn't really know what a test engineer did. I had just spent about 3 years as a military pilot, which you're not doing engineering. Like, you're not like calculating the lift on the wing, right? You're just flying the airplanes, and you get really good at flying airplanes. Don't get me wrong, but I was out of engineering practice, and even going through the Naval Academy, I didn't expect to ever need to use engineering again, because I wanted to be Maverick. Maverick's not an engineer, he's a fighter pilot. And so I was like, that's where I'm going, that's what I'm doing. And
Maverick doesn't do Pythagoras.
No, he doesn't. Yeah, exactly. Who is Pythagoras? Yeah, exactly. So I joining SpaceX, the learning curve was so steep, but my enthusiasm to learn was what kind of kept me afloat, and having the support network of the people around me. There was a guy named Theo who was the test director for Dragon engines at the time. David Heffley, who was my boss. Yeah, I could listen to it. Kevin Mock was amazing. Like Karen, like the whole team was awesome. And so having the support network around me supported me through that really steep learning curve, and onwards to success eventually, but it wasn't overnight. It speaks to my willingness to tackle things that I don't yet know how to do, but want to learn how to do. One of the first projects I had was to develop an LED system that could see through NTO vapor, which is a really dark reddish brown, and as part of an optical micrometer system, so we could measure propellant consumption very precisely. I didn't know anything about LEDs or like light wavelengths through NTO vapor, nothing, or like how to make a circuit board. But talking to all the people I listed and more, and doing some internet research and trying, like having the freedom from the company and from my boss to spend a little bit of money to like try a whole bunch of LEDs.
Here you go to Radio Shack, and here's your credit card.
Yeah, I was ordering samples from Samsung or Philips or whoever saying, hey, I'm thinking about buying a bunch of these LEDs. Could you just send me one or two so I can test them out? And they're like, oh yeah, sure, no worries, have them for free. So we test them out. But I ended up making a circuit board that I designed in a piece of software I had never used before, and then ironed it onto some copper printed circuit board and etched it with muriatic acid in the back of my car. I ended up messing up my like floor mats. Yeah, just to get it done. Like we just.
Gee, that'd be a sight. Imagine that in a car park. This is Nick in the boot of his car melting this thing onto a copper board.
No, it was like 10 p.m. or 11 p.m. I'm out there in the dirt car park of the SpaceX test site making circuit boards.
That's so cool.
But like we had the ability to get done what we needed to get done, and all of the resources of the company were there to support us in solving the problems at hand. Because for every problem that was solved, there were two more waiting for us to be solved. So we just needed to get through them as quickly as we could.
And it's nice being reassured that the resources are there. You can rely on those resources, and when you need them, and if you need them, they're there.
Yeah. Again, it's important to recognize that we weren't spending money irresponsibly. Like the attitude was spend every dollar as if it's your own and it's your life mission to solve that problem. And so if you have to make some decisions, you're like, oh yeah, this is worth it to spend a little bit more to have a high confidence in solving the problem, then do it. And you're trusted to do that. And there's some checks and balances in place, especially for young engineers, because you may not know like where to draw the line there. But equally, I could and literally would go to the Bunnings equivalent in the US and like buy some stuff to help me solve these problems, or go to Radio Shack and like buy some components and put them together, like JCAR. And that was a big transition mentally for me coming out of the military, because the military is a very bureaucratic process, probably by necessity, because the mission is truly life and death in certain situations. But I remember going to SpaceX and like no one really was babysitting me. Nobody was watching me. Nobody cared when I was or was not at work.
No one to yell at you.
Yeah, no one was yelling at me when I needed to take leave. No one was asking me where I was going or why I was going there. Like, you're just treated like an adult and given responsibility all at one time. And so for me, coming out of the military, that was a big transition. I imagine it'd be similar coming out of university and straight into a commercial company.
Yeah.
They're not going to keep tabs on you. You just, here's your goals.
They're trusting you with.
So that was the biggest surprise when I went to Boeing. It was like straight out of university, after people assessing me and marking me so like every single word that I'd written, they would mark it and judge it. And then I come to Boeing and they're just like, "Do you think it's okay? Like, do you think it's correct?" I'm like, "I guess." I was like, "Yeah, sure, why not?" And they're like, "Okay, we trust you." And I was like, "I don't trust myself here." But no, it is definitely like, it's like being taken off the leash in a sense, and then you're like, I'm free. Oh wait, I'm free.
Speaking of university, like what's some advice you give to young engineers, young professionals who are currently in uni or starting their career, or even like high school students who are thinking of pursuing a career like this?
So, maybe I'll start with high school. So the biggest challenge that we face, especially in Australia, is awareness that these types of opportunities are out there. So many times I talk to young students and they have no clue that there is a hypersonic aircraft company, a rocket company within, I don't know how many Ks, 60 Ks of each other, right? The options are there. So we as an industry can do a better job of raising awareness. That's like number one, because we need to tell the 3-year-old who just went and saw, or I guess it wouldn't be that old yet, but the 3-year-old who watched Top Gun, right? That you can do that. Like, that is a real possibility for you.
It's not just a movie. That's a real plane.
These are real things.
You can do that.
Go and make that happen for yourself. And it takes a bit of hard work to do that. But anyway, so I think inspiring really young, especially some of the less represented demographics. So whether that's women or people of color or like gender diversity, whatever. Like, if you look around, some of the typical engineering office, it's probably a lot of white guys, like realistically. And so raising awareness and providing encouragement to all those underrepresented classes, I think, is something really important that we as industry can do.
Because they bring such a diversity of thought as well.
Exactly.
Which is most important in such big industries like this. Diversity of thought and creativity, and having different inputs from different people who have different backgrounds, like immensely important.
Yeah, it's critical. It's critical. You can avoid problems that you would not have even recognized had you not had those people in the room. And then moving on, high school, if you do want to go into a STEM career, I'm not sure what the equivalent is in Australia, but in the US we have advanced placement classes, AP classes. So basically if you're doing well in your classes, you can volunteer to take an extra hard physics or an extra hard chemistry.
Oh, really?
Which is cool. So, but you have to work hard to get there.
Yeah.
But then that hard work is both recognized by universities, sometimes in the form of credit.
I think we do have
classes.
That. Yeah, we do have some of those too. Yeah.
Yeah, but you've also now, maybe unknowingly, built a personal habit of working hard, right, and not being satisfied with the standard physics class or chemistry class. You're like, no, I want to know more, and the pursuit of knowledge is such a critical aspect of being a good engineer. Doing that through high school and then into university, pursuing a degree that captures your interest, because if you're naturally interested, you're going to be more motivated to learn. It's going to come easier to you. You're not going to feel like it's such a chore. And naturally, when you graduate with the degree in whatever that thing is that you're naturally interested in, you're going to be lined up to go pursue a career in that industry. So it is a double benefit. There are obviously some degrees that there aren't as many jobs out there for, and that's worthy of being cognizant of. There's been some proposals in Australia to create space-specific degrees. And I'm actually I'm generally opposed to this idea because I feel like it would corner a graduate into that industry rather than encouraging graduates to pursue more general mechatronics degrees or mechanical engineering degrees, aerospace engineering degrees. Broad. They're much more broad, and the fundamental skill set that exists can be applied to space super easily. We didn't hire a single space engineer at Gilmore Space. We don't need them. We need intelligent people who are highly motivated, want to work on an amazing mission, and have a fundamental ability to learn hard things. And then I can teach you anything you want to know. You'll probably teach yourself what you want to know. I don't even have to as a manager or leader in the company. You're just going to show up and say, what about this? What about that? I did some research. I read this book. Here's what I want to do.
And if you have a broad understanding, like just mechanical, that way you can see other things that a space engineer specifically wouldn't see because you've done other courses related to it.
That's it. Yeah,
definitely.
And the fundamental skill set, the math underlying all of the world is physics and engineering and chemistry. So if you have a fundamental background in those things, you can go into whatever industry you want. And once you're past, let's say 2 or 3 years in your career, people aren't looking as much at your degree anymore. They're saying, well, what did you do at your last job? And maybe it didn't line up with your degree at all. But if you, again, have demonstrated the ability to problem solve and learn hard things, you can apply those skill sets to almost any business across the board.
And I think it's also just being hyper aware of the industry that you're going to go into as well, understanding what projects are currently going on in that industry, what companies exist, and what skills you're going to need, because then that way you can sort of attack it from any angle that you want then, if you can understand it holistically. Whereas if you're just looking at aiming at one single role, like I want to be a mechatronics engineer on this rocket and on this, then you're going to just narrow that down, and then you're going to get there and they're going to ask you, do you know any of this other stuff? And you're like, no, because I've only just focused on this.
That's the only thing I'm aware of. I'm probably not the best example because, like I said early on, I was like, nope, I want to fly F-18s. That's what I'm going to do. And so that, a bit of the warning, I would say. So as you're going through university and studying whatever the discipline is, pay attention. Actually sit there and let an expert in the field show you how these things work. Your professors are super smart. And when I went through it, I didn't appreciate that enough. And so I didn't pay close enough attention. I was like, I'm never going to use this engineering stuff again. I'm going to go be a pilot. Leave me alone with all this nonsense. I got decent grades and got through everything, but I could have had a step change in my understanding and probably shortcutted my learning curve at SpaceX because I wouldn't have had to break the books out again and go, oh man, how do I do this fundamental engineering stuff? So pay attention, absorb it. There are very few opportunities in your life where you have subject matter experts at your disposal every single week trying to teach you the thing that they're a subject matter expert in. Like, take advantage of that. It's such an awesome opportunity.
And it's available to you at any time, really.
I know.
Like, it's so easy to just reach out, send them an email, send them an IM, like, just go for it, honestly.
And ask the follow-on questions. Like, maybe they're teaching you about one thing, but go a level deeper and say, hey, I'd really like to understand this better.
Yeah.
And, they'll be excited to share it with you because they're probably an engineering nerd like you are.
I also think it's also important to engage industry as well and hear from professionals like yourself, and like listen to things that talk about the industry a little bit more. I mean, like, listen to podcasts, read news, what's going on in that industry, because those people are the ones that are in the industry. They are the industry. Whereas, like, sometimes I feel there's a bit of a disconnect between professors and the industry. Sometimes that's what I've experienced so far. But I think that it's getting better, and that connection's finally getting built, and it's finally like there's a bridge being built between those two, and I think we're moving in the right direction, slowly but surely. I think we've gotten there.
And it's a different mindset, but keep in mind, like, commercial companies have a different purpose than a university. Like, a university's purpose is the pursuit of and transfer of knowledge, and so they're always going to be asking these like far-fetched 10-year problem type questions. How do we solve this thing that's going to maybe be a problem in 10 years? And so you end up, especially as you go down like master's degrees or PhDs, with these very theoretical problems, which are great and need to be considered. But the second you step foot into a commercial company, I don't necessarily care about the 10-year problem. I need a vehicle to fly tomorrow. How do we get that vehicle to fly tomorrow? And so they're fundamental different drivers between those two types of organizations that I think can be complementary if you acknowledge that and say, hey, university, we want you to develop the kryptonite that we know we're going to need eventually. Like, go and start making that happen, figure out what it takes, and then at some point we'll meet in the middle and we'll say, all right, we're ready for kryptonite. We've flown at hypersonic speeds up to Mach 20, and now we need something better. And what do you guys have for us? But figuring out how to take advantage of that and structure incentives in a way that is sensible. So
I think that really touches on the collaboration space and talking to others who have knowledge in that area, and just it's about knowing who to ask. And that's what I want to ask as well. Can you speak to the importance of, I guess, collaboration and teamwork in the space industry specifically, and any advice on how to build successful partnerships with others working in the field as well?
Yeah, it's a little bit tricky given the commercial incentives that we kind of discussed earlier, but if you can partner with government agencies and find ways that there's mutual benefit, government agencies, universities, other commercial companies, there has to be some sort of mutual benefit. And one thing I've found really useful is that you have to remember that on the other side of the email or on the other side of the phone is a person with like a life and a family and everything else going on. And so if you can connect with them as a person and say, how can I make you successful? Like, what is it that you're going to go home at the end of the day going, oh my gosh, partner, I have this amazing opportunity. We're going to work with Hypersonix. We're going to do this awesome stuff, and get excited about the opportunity to work together. And whether that is with, let's say a government agency that is considering giving your company a grant, like, say, how money is great, but how do I make you successful as a person? And they're going to be much more motivated to work with you and make stuff happen.
How do you give them the skills that they need and the opportunities that they need to learn from?
They're sitting on the other side of the table with a performance review coming up where their boss is going to say, hey, have you given the money to the right people, and has it produced the right results? And so if you can just understand what their motivations are and say, oh yeah, okay, well, I want to make you successful. You give us money, we'll go away and we'll produce this amazing capability and we'll slap your sticker on it, and you can take that to your boss and say, look what I did. I partnered with these guys and we made amazing things happen. So I think partnerships, really remembering that there are people on the other side of the table is important, and then finding meaningful ways to collaborate that are along the company's desired roadmap already. What isn't really effective is where partnership with a university maybe creates this desire to pursue a very niche opportunity that maybe the company doesn't really need. And so it's kind of forced collaboration for the sake of saying we're collaborating, not for the sake of producing
just to tick a box,
a desirable product. And so I'm honestly not sure if it's like I've moved to Australia and Australia is different, or if I've moved to Australia and moved into a slightly different role where I have more visibility. But it does seem like Australia has a tendency to force collaboration more than I think I see in the U.S.
Yeah, okay.
Like in the U.S., it's every company for themselves. The tallest one standing is the winner type of thing. Where I'm sure you guys have heard the tall poppy syndrome here, where it's like, if anybody's standing out, they're going to get cut, and everybody else kind of grows very slowly together. And so I think there's a cultural aspect to it. But I would love to see the Australian organizations take a bit more risk, bet on some companies that are moving fast and creating value.
Moving hypersonic.
Exactly. Support those companies.
How do you balance your demanding workplace tasks and responsibilities as a whole? Like, what does your work-life balance sort of look like? What advice would you give in that regard?
So I don't know if I'm the right person to give advice on this one. So the SpaceX mentality, it wasn't that I had to force people to stay at work at SpaceX. Often I would actually have to encourage the team to go home because they were so excited about what we were doing. And honestly, every individual could go home at the end of a single day knowing that they had a meaningful impact on forward progress.
That's so cool. Yeah.
So it almost becomes your hobby. It's not work. Like,
that's so good.
I'm being given the opportunity to go to this place, to work with amazing, supportive people and deliver hardware in the form of a spaceship that's going to go to the space station. Like, I'd probably do that for free, but then you're going to pay me to do this? Yes, please. So it was very easy, especially as a young engineer. I had a dog at home, but she had a dog door, so she could take care of herself for the most part.
That was strategic.
Honestly, often the thing that would force me to go home was to go and feed the dog. So otherwise, I'd want to keep going because there's so much work to be done. I don't really think of it as a work-life balance as much. It's just this like blend of activities that I'm choosing to participate in, and some of those are related to the company that I happen to be with. Some of those are related to my amazing wife Amy. Some are related to our dog or our family or whatever. And so I see it as just this like big blend. But I know and have experienced Australia is quite different. Australia seems to have a much heavier emphasis on the life side of the work-life balance, and definitely value to that. I don't want to criticize that in any way, but it does make it challenging to move at the pace that some of the U.S. companies are moving.
Yeah, so, I think so, definitely. I've seen that a lot throughout high school, growing up in like a coastal town where people would prefer surfing than going back and doing homework, and it would slow production down a lot.
I mean, that's the reality, and it's okay to say that. Like, that's not saying necessarily negative things, but SpaceX average work week when I was there was about a 50 to 55 hour work week, and that was average. There were weeks where it was much more. There were some weeks where it was a little bit less because we were at a lull maybe in the manufacturing process or whatever, and we would take advantage and go home a little bit earlier, whatever, go to the beach, in LA. But if you take that 55-hour work week and you compare it to the Australian 38-hour work week, where the other thing is people are not generally working on weekends in Australia, right? In the U.S., you probably I would spend one of my weekend days doing stuff, playing a bit of catch-up. You add that up and multiply by the number of people in the company, and you're like,
that's a lot of extra time.
Years of difference every year in how much progress you're making. And you just can't argue with the simple math. Elon, I think, kind of infamously said it's not enough to work smarter. You have to work smarter and harder, not smarter, not harder.
No, definitely. I think it is a very different work-life balance here in Australia, that's for sure. If you work on a Sunday, that's okay because you're sort of enjoying working on spacecraft in your spare time. Like that sort of thing. I've noticed that at Boeing as well. I go home and I'm like on Saturday, I'm like, I might just keep cracking on with this presentation because it's actually going to be really cool and I can't wait to present it. It's going to be great.
Yeah, that's it. You take pride in it. And I struggle a little bit sometimes. Like my wife has to kind of remind me that, hey, you got to spend time like here as well, and not just physically here, like mentally here, not thinking about work all the time. Because if I'm driving or sitting on the train or whatever, my mind is wandering a bit, and I'm thinking about how to problem solve whatever the thing is. It's just my natural.
And I think as engineers, we tend to just focus very much on the solution, and we're like, and when the solution, we don't have a solution yet, we're like, what is the solution? We're just sitting there like day and night, whatever you're doing, always zoning out, thinking about how can I go around this and attack this.
But I will say equally healthy is like when you take a bit of time away and actually separate yourself. So 2 weekends ago, my wife and I went to Heron Island, which was a really cool experience. Like spent 4 days on the island, like hanging out with the turtles and stuff. And that like clarity and like lack of in-your-face pressure to put out the day-to-day fires, but ability to like think bigger picture and more strategically is really useful every once in a while to like keep things in perspective.
Yeah, awesome.
So I've got a bit of a hypothetical question for you here, Nick.
Shoot.
Let's say if the wisdom that you've acquired during your spacefaring journey were a rocket, what would be its fuel? In other words, what's the most valuable lesson that you've learned in the industry, and how would you share it with those who are just beginning their own space odyssey? And like, what could their fuel be?
A rocket has essentially two fuels, right? There's a fuel and there's an oxidizer.
Oh, here we go, getting technical.
I would say that my fuel would probably be my attitude, and my oxidizer would be intrinsic motivation. And so if you're naturally motivated to do things, like tackle challenging problems, and then you have a good attitude when those problems blow up in your face or present you with new challenges you weren't expecting, then I think you'll have a really high chance of success.
Yeah, couldn't agree more on that one, to be honest. And I think you just got to find out what your own two components are for that fuel and see if they work together. I guess on an end note then, Nick, let's say hypothetical question here. If you were to identify one really pesky problem within the current engineering world as a whole, so the engineering industry as a whole, and you could strap that problem, strap it to a rocket, fly it into the depths of space, and then never see it ever again, what would you choose? And how could you suggest first solving it here on Earth without having to send it to the depths of outer space?
All right, a pesky engineering problem.
Yep.
I mean, I think the problem that needs to be solved is reliance on non-renewable sources of energy. We need to get that one sorted as quickly as possible. The Earth is warming up, and we can have discussions about whether global warming is real or not, but I trust in the scientific process, and I trust in what the scientists are saying. And
got to decide whether the Earth's flat yet or not.
Yeah, TBD. I'll let you know once I get to space.
Yeah, thanks.
Sounds good.
But yeah, I think having sources of renewable energy, if we could solve that problem, that would be the one. So I guess I would send non-renewable energy sources into the depths of space so that we could focus on renewable energy sources.
Awesome. Take the problem away to somewhere else.
That's
I like
right.
it.
So good. They're already out there. We just got to work on making them less expensive than the non-renewables.
That's so good.
Yeah, awesome.
Thanks so much, Nick. It has been an awesome episode. We really appreciate your time, and like, I'm civil. I don't do any mechanical stuff, and that's super interesting to everything you.
Yeah, I think everybody can really appreciate how awesome this aerospace industry is evolving into, and the potentials for it as well. So thank you for coming on the Engineering Buzzcast, and thanks for spending your time with us here. Thank you so much. I'm sure a lot of people got a lot out of what you talked about here today, especially relating to careers, a little bit what's going on in our industry, and as well as importantly, what's buzzing in the industry.
Absolutely.
So thank you very much, Nick Lindsay.
Thanks, guys. Appreciate the time.
No worries. Thanks. Now, with all of that said, thank you so much for listening. We personally hope you got as much out of that as we did. Now, remember, if you've enjoyed what you've heard here today, it doesn't take very long, so just chuck us a quick, cheeky review on your preferred podcast platform. Or if you want, chuck us some coffee money, because trust me, as an engineering student, that goes a really long way. And whilst you're at it, stay up to date by following us on all of our respective socials. You've been listening to the Engineering Buzzcast with your hosts, Jacob Primus and Daniel Hardy. And until we meet again, we'll see you in the next episode.
See you in the next episode.
See ya.
The top job is that of the engineer. This requires a great amount of ability and training in mathematics, and you should have some courses.